Hi everyone, welcome back to our YouTube channel InfinityGreedy. In this video, we are going to write down the algorithm for quicksort. We have already seen several examples where we have traced this algorithm, but in this video, we are going to write that algorithm formally. So I'll get started with what we have traced in our previous example. What we do, we basically check whether pivot is greater than equal to a of I, right? If this is true, what we do, we increment I, and if this is false, what we do, we decrease. We check for pivot is less than a of j. Now I hope all this has came into your muscle memories after solving 2 3 questions, right? If this is true, we decrement j. If this is false, we check whether I is less than j. If this is true, that what we do, we swap a of I and a of j, and if this is false, what we do, we swap pivot element with a of j, and here's the partition happens, right? This was the basic fundamental we were using to trace the example. Now if you understand this, and what we need, you need one function for partition, one for swap, and one for quick sort. Okay, so let's write first this partition function. Okay, so partition. So if you remember, let's say I have an algorithm 15, 7, 12, 8, 21, all this. So what we do, first we define pivot, and we then define I, then we define j. We consider this as low or not this as j. We consider one more element and consider this as high, and we define j. Are you getting it? So we'll do that. So we'll do partition function, partition L of h. What? First we'll write the pivot. So pivot element will be your a of low, right? That is your first element. And I will be your low element and j will be your high element. Are you getting it? So what we do then? We check for the condition. I is, so what condition we check? We check for pivot is greater than equals to, what we do? We increment I. So what you do? You increment I till when? While this pivot is greater than or equal to a of I. Okay. Otherwise, what you will do, if this not doesn't happen, then what you will do, will decrement what, j until pivot is less than a of j. Correct? Then what we do, we check whether if I is less than j. If it is so, what we do, we swap. What we swap? A of I with a of j. Right? Otherwise, what we do, we swap pivot. Pivot is nothing but a of l. You can consider this as pivot, and a of j, and we return j. Return j. So this is how partition function look like. I hope if you have seen our previous video, writing down this won't be a much issue. Now after partitioning, what we do? I have done with the partition. So you get subarray again. This is the partition or the pivot element. With that you get these as partitions. Now this pivot as it became at the right position. But now you need to again apply quicksort on these array. So I'll write the another function that is quicksort. Now this quicksort function is again go from low to high, and it will check if this condition is true, then whatever j you have got, j equal to partition L comma H, and then again you apply quicksort. Quicksort, so I was telling you this, right? So apply quicksort on this and apply quicksort on this. That is quicksort on L comma J and quick sort on j plus 1 to high, correct? So this is how your algorithm looks. So one more function you can write, that is swap. Okay, I think swap you can write. How you can write? By using a temporary variable. So this is how it looks. So important is this function, how you write for partition and how you recursively call quicksort, right? If you remember in our first video of this, we have already discussed that. What we have discussed that quicksort works on three principles: pivot, second is partition, and third is recursive call. So we have seen partition function, we have seen, and recursive call we have seen, and we have seen various examples. So if you like this video, please do like, share, and subscribe. In our next video, we are going to derive time complexity for best, average, and worst case, followed with the space complexity. Thank you.